Bismillahirrahmanirrahim. In this video we will study about some definition of the sampling theory and sampling distribution. The first heading is the population. We will also use the concept of population and sample in next topic, testing of hypothesis. So these are the most important definitions. What is the definition of population? A set of all individuals or objects having some common observable characteristic constitutes a population. This word is most important, some common observable characteristic under study. For example, suppose if you collect the data of the first year students and you want to study or analyze the characteristic of the boys and girls, male or female. So in statistic, this is not a population. You cannot study or analyze the characteristic of boys and girls as a class, because this class is a heterogeneous. There are two different types of data, male or female, or characteristics of the male and female. But suppose if you collect the data of this class of first year class and you want to study the qualification or analyze the IQ test, so this class will be a population, because the qualification of this class is same of all students, boys and girls, but the distribution in terms of male and female gender wise distribution, and you want to study the characteristic of the total data, is not a population. So some common observable characteristic under study. Population may be finite or infinite. Finite population, a population is said to be finite if it consists of a finite or fixed number of elements, items, objects or observations. For example, all university students is a finite population. Number of patients admitted in a hospital is a finite population. Infinite population, a population is said to be infinite if there is no limit to the number of elements or it consists of an infinite number of elements. Unlimited. For example, number of all points when the temperature is increased 1 degree centigrade, because if temperature increase from 15 to 16 degrees centigrade, there are infinite points between 15 and 16, because the variable is continuous. Temperature increase or decrease continuously. Number of all points on a line, etc. Next definition about sample. A subset or part of the population is called a sample from that population. Part, portion, subset of the total population is called sample. A sample may be taken or collected with or without replacement from a population, taken or selected. If the sample is taken with replacement from a population, the element selected is returned to the population. After selection of the element, again returned in the same population before drawing the next element or before drawing the next sample. In with replacement, an element can be selected more than once. If you select one sample from the population and then again replace in the same population, so you can select again. It's called with replacement. Or without replacement, if the sample is taken without replacement from a finite population, the element selected is not returned to the population before drawing the next element. In sampling without replacement, an element can be selected only once, one time, because if you select one sample and then without returning in the population, select another sample. So you will select any sample one time without replacement. And the process of selecting the sample is called sampling. The process of selecting the sample is called sampling. But what is the purpose of sampling? Purpose of sampling is to collect information that is used for making generalization about the unknown population parameters. Suppose if you select a sample from the population and then calculate the sample mean, and sample mean is a representative of the population, total data, like a CR. CR is a representative of the all class. The purpose of sampling is to collect the information. For what purpose? For making generalization of unknown parameter, population value. If you calculate the mean, standard deviation, etc. from the sample data is called statistic, and from population data is called parameter. So this is our next head definition: parameter and statistic. This is a singular term, statistic. A numerical values such as mean, median, standard deviation, correlation, etc. calculated from the population is called a population parameter or simply parameter. Parameters are fixed number and denoted by Greek letters. For example, mu represent the mean, sigma standard deviation, rho correlation. So if you calculate the mean, median, mode, etc. from the total data, population data is called parameter. And why this is fixed number? Because if you calculate the mean, standard deviation 1 time or 2 times, 3 times, 10 times, the result will be always same. A numerical value such as mean, standard deviation, etc. calculated from sample is called simple statistic or simple statistic. The statistic varies from sample to sample from the same population, because if you select one sample and calculate mean, then second sample and calculate the mean, both mean will be different, may be different. So sample mean or sample statistic varies from sample to sample from the same population. It is denoted by Roman letter. For example, X bar represent mean, S standard deviation, correlation, etc. Next definition: simple random sampling. There are different sampling method in statistics, but only two are included in your syllabus. First is the simple random sampling. It is defined as a method of selecting a sample. Method of selecting a sample is called sampling. So what is the simple random sampling? A method of selecting a sample of a given size, sample size represented by small n, from a given population, capital N, represent population by capital N, such that all possible sample of n combination n. So all possible sample will be n combination, and n combination and permutation you have done in mathematics used for all possible samples. All possible sample has an equal probabilities of selection, equal chance of selection. In this type of sampling, each unit of the population has an equal probability of being selected, and each unit not previously selected has an equal probability of being chosen. Suppose there are three population size A, B, C. If you select first A, then B, then C, or if you select first B, then A, then C, all has an equal probability. So an equal probability being selected and not previously selected. Both has an equal probability of being chosen. In order to draw simple random sample, the commonly used methods are random number table and calculator. Random number table is given in your book and random number key is given in calculator. If you press the random number key, a number will appear on the screen of the calculator. If you press again same key, a new number will appear on a screen randomly. Randomly means without any sequence. So with the help of random number tables and calculator, you can select the sample. In random number table, first we select any line, any column, and then according to the number we select the numbers. This simple random sampling procedure can only be used if the sampling units can be easily identified and the population is small and homogeneous. This population is small and homogeneous, then we use the simple random sampling method. This is the most important thing. If the data are non-homogeneous, simple random sample might not be representative of the population. Then we use another method, it's called stratified random sampling. Stratified random sampling. It is defined as a method of selecting a sample of given size n from a non-homogeneous or heterogeneous population n, called stratified random sampling. Suppose this is the total population, this is the faculty of science or pharmacy, and there are 5 different classes: first year, second year, third, fourth and fifth year. According to qualification, total population is heterogeneous. And what is the purpose of method of the selecting the sample? In stratified random sampling, the data or area, this is the data or area to be sampled is divided into groups or classes called strata or stratum. Divide the heterogeneous population into different groups according to the qualification. Suppose first year, second year, third year qualification, fourth year and fifth year, and each part is called strata or stratum. And items within each strata are homogeneous with respect to the characteristic under study. Items, observations, objects are homogeneous because suppose this is the first year population, according to the qualification this population is homogeneous. Total population is heterogeneous according to the qualification. So first we divide into homogeneous group, and then from each strata simple random sample is taken. Why? Because population is homogeneous, and overall sample is obtained by combining the sample of all strata. Suppose if you select sample 1, n1 from this part, n2 from second part, n3 from third population, n4 from fourth subpopulation, n5 from 5 subpopulation, and n1 plus n2 plus n3 plus n4 plus n5 will be equal to total sample size. And same as individual population of each group or each strata, if you add all the population will be equal to capital N total population. So these strata are non-overlapping, comprises the whole of the population. N is equal to n1, n2, n3 and so on up to nl. The sample sizes within the strata are denoted by n1, n2, n3 and so on respectively. If a simple random sample is taken in each strata, then total sample size equal to n1 small n1 plus small n2 and so on up to last. The whole procedure of selecting the sample from non-homogeneous population is called stratified random sampling. What is the procedure? First we divide the total heterogeneous population into homogeneous groups, and then we select the sample from each homogeneous group by simple random sampling method. And according to the size of the population, we select the sample according to the size of the population. The method is called proportional allocation method. But we will study only definition in this syllabus. Now next definition, sampling distribution. Before sampling distribution, you have done 2 different types of distribution. Number 1 frequency distribution, number 2 probability distribution. As you know that in frequency distribution, we distribute the frequencies or observations and then analyze the data. We calculate the mean, standard deviation, etc. In probability distribution, we distribute the probability according to the random variable x, and then we also calculate the mean, standard deviation, etc. For mean, we use the mathematical expectation you have done in probability, Ex. Same as frequency distribution and probability distribution, in sampling distribution, we will distribute the sampling statistic according to the values of the sample statistic. So if we distribute the sampling value, sample statistic, in the form of table, the table is called sampling distribution table. The method of the calculating the mean, standard deviation is same as the frequency distribution, because in this we will also count the values of the sample statistics in terms of frequencies. In probability distribution, we distribute the probability according to the value of the random variable x. Suppose if you throw a coin 3 times, number of heads may be 0, 1, 2, 3. X is a random variable for the number of heads. You have solved this question many times in probability. If x is equal to 0, 1, 2, 3, the probability of x is equal to 0 will be 1 upon 3. Probability of 1 and probability of 2 will be equal to 3 upon 8, 3 upon 8, and probability of 3 is 1 upon 8. 0 head occur 1 upon 8 one time, 1 head occur 3 times will be 3 upon 8, 2 heads occur 3 times 3 upon 8, 3 heads occur 1 time 1 upon 8. Sum of the probability will be equal to always 1. So if you distribute the value of the probability in the form of table with the help of random variable x, is called probability distribution table. So in this sampling distribution, we will distribute the frequency. Instead of frequency, we will distribute the sampling statistic. This is the most important definition, because in this we will cover 3 different important definitions. The value of a statistic varies from one sample to another, even if the samples are selected by the same procedure from the same population. You have done, and I have explained in the definition of a statistic. Value of the statistic vary from one sample to another, either the sample are selected by the same procedure from the same population. Number second, if you convert the sample statistic in the form of table, for example, the distribution of probability distribution of a statistic is called sampling distribution. For example, the distribution of the sample mean is a sampling distribution of mean, and sampling distribution of sample proportion is a sampling distribution of proportion, and so on. So if you distribute the sample mean, sample proportion, sample standard deviation, etc., according to the value of the observation, the table is called sampling distribution table. And after the sampling distribution table, you know that we analyze the data. You have done in frequency distribution, you have calculated the mean, standard deviation, etc. Same as in probability distribution, you have calculated the mean, mathematical expectation, and standard deviation, etc. Same as here, you will calculate the mean and standard deviation. If you calculate the mean of the sampling distribution, the mean of the sampling distribution of mean will be always equal to population mean. And the standard deviation, this is the third important definition, the standard deviation of the sampling distribution of the statistic is called the standard error of the statistic. So if you construct the table of the sample means and then calculate the standard deviation, this standard deviation is called standard error. And what is the difference between standard deviation and standard error? You know that the standard deviation measures the variation of the data from mean between the data, and standard error measure the variation of the data between the sample means, not between the data of a statistic. So we will prove this with the help of this example. This is a very simple example. Population size and sample size is very small. First we will draw all possible samples, then we will convert in the form of table, sampling distribution table, and then we will calculate the mean of the sample mean and standard error, or you can say standard deviation, and then we will compare with the population mean and standard deviation. So suppose that the population consists of n equal to 5 of observation, numbers are 1, 2, 3, 4, 5, draw all possible sample of size 2 with replacement. And for each sample compute the sample mean. Each sample compute the sample mean. And then construct with the help of this sample mean. Then construct sampling distribution of mean. And then calculate the mean of the sample mean represented by mu x bar, mean of the mean. And standard deviation, sigma of x bar, is called standard error. Of what? Of sampling distribution of mean. Also compare with the population mean mu and standard deviation sigma. Population mean represented by mu, I have explained in the definition of parameter, standard deviation by sigma. So first we will draw possible sample with population size 5, sample size 2 with replacement. N is the 5, small n is the 2, all possible of sample size 2 with replacement. We use this formula, n power n, 5 power 2 is equal to 25 samples can be made. You know that if you throw a coin one time, so 2 power 1 will be 2. If you throw a coin, there are two sides of the coin, 2 times 2 power 2 is 4. Same as there, if you draw a possible sample of 5 sides, 5 population with size 2, power is 2, will be 25 sample. So first we will draw 25 sample with size 2 mean, with replacement mean, first write 1, then again replace in same population, you can select another sample 1 again. Same as second sample, first time 1, second time maybe 2, then 1, then 3, then first 1, second time 4, first time 1, second time 5. Same as if you select first time 2, second time maybe 1, both are different. In first time 1, second time 2. The first sample 1, second sample 2. The first value 1, second value 2, but here first value 2, second is 1. Mean will be same, but samples are different. So maybe 2, 2, 2, 3, 2, 4, 2, 5, 3, 1, 3, 2 and so on up to last 5, 5. There are 25 sample, and then calculate sample mean x bar. Mean of the 1 and 1, 1 plus 1 divided by 2 will be 1. Mean of 1 and 2, 1 plus 2 divided by 2 will be 1.5. 1 plus 3, 4 upon 2, 2. 1 plus 4, 5, 5 upon 2, 2.5. 1 plus 5, 6, 6 upon 2, 3. And so on, calculate all 25 sample means. And then construct the table. The table is called sampling distribution of x bar. In this we will distribute the sample mean. The possible values of this sample means are 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5 and 5. So construct the different group for the value of 1, 1.5 and so on up to 5. All possible values are 1, 1.5, 2, 2.5 and so on. And how many 1 occur? 1 time. This is called frequency. 1.5 2 times. Frequency of 1.5 is 2. 2 occur 3 times. 2.5 4 times and so on, 5 times, 4 times, 3 times, 2 times, 1 time. Total number of observation will be 25 because there are 25 sample mean. And then calculate after the table mean of the mean and standard deviation of the mean is called standard error. So the formula of the mean is same as the frequency distribution, but notation are different. In frequency distribution here we use x bar only, but here we are calculating the mean of the mean. Notation will be mu of the x bar. Instead of xi, here we are using x bar, we will write here x bar. So in numerator we required the product of the frequency and x bar. So we will multiply frequency by x bar, multiply 1 by 1, 2 into 1.5, 3 into 2, 4 into 2.5. You will obtain these values, and sum of the all values will be 75. You have done in frequency distribution. Numerator is the 75, denominator total number of observation 25, the mean is 3. And for standard deviation, you have used this formula in frequency distribution table for standard deviation with s here and here xi here x bar, but instead of xi we are using here x bar. Instead of x bar we are using here mean mu x bar. We will write here mu x bar. First we will subtract this value from this value and square of this term, then multiply by corresponding frequency, and sum of all values will be numerator term divided by number of total frequency. So first we will calculate individual value of each group. First x bar 1, mu x bar 3, 1 minus 3 2, 2 square 4, 4 into f, f is 1, 4. Second value of x bar 1.5 minus 3 is equal to 1.5. 1.5 square 2.25. 2.25 multiplied by frequency is the 2 will be 4.5. Same as for all, calculate each term, and then sum of the values 25, and numerator is the 25 divided by 25 will be equal to 1. Standard error is 1. Now then compare with the population mean and standard deviation. So there are 5 observations of the population data. Add all the values 1 plus 2 plus 3 plus 4 plus 5, you will obtain 15. Number of observation 5 will be equal to 3. So both are same. Mean of the sampling distribution 3, mean of the population data is 3. So mean of the sampling distribution is always equal to population mean. This is proof, but proof is not included in your syllabus. We have proof here numerically. Now this is the notation of the population standard deviation sigma. Individual value are 1, 2, 3, 4, 5. Mu is the mean of the population data is 3. We will subtract mean from each value 1 minus 3 square plus 2 minus 3 whole square and so on, 5 minus 3 whole square. 5 plus sign because this is the summation sign, means add all the values 1 by 1 and then divide by total number of observation 5. Simplify this term, you will obtain 10 upon 5 equal to 1.412 after square root. So population standard deviation is 1.412 and standard error is 1. You have calculated standard error is 1. So standard error is less than the population standard deviation always. So from this you can observe, you can conclude that standard error less than standard deviation means standard error minimize the variation of the data because we calculate the variation between the sample mean. Okay, Allah Hafiz. Next time we will start new topic, testing of hypothesis. In testing of hypothesis we will use the concept of sample, population, statistic, parameter, standard error, etc. Allah Hafiz.